This conference will now be recorded.
All right, everybody, it is 2:01. Good afternoon, everyone. Thank you for all being here today. My name is Terry Ann Palo, and I'm a regional planner with the Treasure Coast Regional Planning Council. Today's topic is Innovating Coastal Resilience, exploring the FIU Future Shorelines Project. Before we begin, I'd like to take a moment to acknowledge the funding that made this speaker series possible. This event is supported by the Florida Department of Environmental Protection's Resilient Florida program, which is dedicated to enhancing the state's resilience to flooding and sea level rise. The Treasure Coast Regional Planning Council, as a regional resilience entity, plays a key role in coordinating these efforts, providing technical assistance, and collaborating across counties and municipalities to develop strategies for mitigating the impacts of climate change. We're incredibly grateful for their support in fostering this important conversation. Just a little bit about the Treasure Coast Regional Planning Council. We were established in 1976 as the only regional forum where elected and appointed leaders from Indian River, St. Lucie, Martin, and Palm Beach counties come together to address complex regional issues. TCRPC works on strategic solutions and builds consensus around key goals in areas like urban design, economic development and transportation, emergency preparedness, and natural resources. Comprising of 19 local elected officials and 9 gubernatorial appointees, TCRPC plays a vital role in shaping the future of the Treasure Coast through collaborative planning and coordinated action. And now it's my pleasure to introduce today's speaker, Dr. Randall Parkinson. Dr. Parkinson is a coastal geologist specializing in the effects of climate change and urbanization on the built natural environment. He is a registered professional geologist with more than 35 years experience working along the coast of the northern Gulf of Mexico, America, Florida Peninsula, Georgia Bight, Costa Rica, and wider Caribbean. Dr. Parkinson's research interests in the natural environment are focused on the effects of past, present, and future sea level rise on the intercontinental shelf, barrier islands, indigenous shell works, wetlands, oyster bohemes, lagoons, and estuaries. He is especially interested in the processes of above and below ground sediment and soil accumulation that affect surface elevation, hydroperiod, and landscape evolution under conditions of accelerating Anthropocene sea level rise. Dr. Parkinson is also experienced in conducting vulnerability assessments and preparing adaptation action plans for the coastal areas subject to climate change stressors. And with that, I will stop sharing my screen and hand it over to Dr. Parkinson.
Well, thank you, Terry, and remind me to shorten that description of my bio. But hey, hi everybody, and I'm really pleased to be here on behalf of the FIU team to present the geospatial tool called, and this is the living shoreline element of it, but the broader tool is called Future Shorelines. And this afternoon I'm going to do not only the application of this sea level rise submergence simulation tool on how we think about living shorelines, but also how sea level rise will impact a lot of the ecosystem services of our coastal waters that we depend on for quality of life as well as driving the economy. So let's see. Can I share my screen then, Terry? Are we all hooked up here?
Yep, you should have control.
Okay, so let's see. I'm not used to. Okay, let's try that right there. Okay, so this project is about Future Shorelines, which is a very unique online geospatial tool that, although as I mentioned, originally designed for assisting practitioners in how they might locate, design, and monitor living shorelines, but has much broader application to coastal zone management, and it's a decision support tool that one could look at as they think about resiliency and interventions and so forth that might be possible to sustain the capabilities of a lot of the resources that we depend on. And this was funded by the U.S. EPA Region 4 Wetland Development Program. So you're going to benefit not only from the looking at how it operates with living shorelines, but also a lot of other elements of the estuary that I think will be relevant to the Regional Planning Council as you think about resiliency. So let's see here. Let's go. I'm not familiar with. Okay, so here's how we get started. So the submergence tool that we're going to be talking about, it's different from a lot of the other simulations in that we're using locally derived tide data that informs these trajectories that NOAA has generated. So NOAA has trajectories for, I think there's 15 different locations in the state of Florida. We're using here at Trident Pier at Port Canaveral because it was closest to or within the study domain on here. And so these are the trajectories. And so what you see here, these are elevations relative to the year 2000. And then it just starts here. And then you could see these different lines, and then there's banding about them, which is the uncertainty. But they start off with low, which is essentially historical record. And then they progress intermediate low, intermediate high, and high. And those are simulations that are essentially based upon ever more amounts of CO2 in the Earth's atmosphere, which then drives climate, weather, ocean circulation, ocean temperature, all of this stuff. So it's a very, very robust model. And there's some uncertainty, and that uncertainty increases with time. Here it goes up to 2100. What you can see then, the lowest is just business as usual, would be 1.5 feet towards the end of the century. And the high here is almost 7 feet. Importantly, the work that I have done and published on it with colleagues, we looked at all of the NOAA tide gauges, 14 of them around the state. We looked at the rates of sea level rise as far back as the data would go from the 90s and then this century. And what we recognized was that our current rate of sea level rise is tracking between the high, some of them are at the high pace, some are at the intermediate, but none of them, intermediate high, none of them are low, intermediate, low, or intermediate. And because we are making no progress on carbon emission reductions, our modeling now that we do only considers the high trajectory, this trajectory right here, because we're already on that pathway, and it's, in our opinion, it's likely to exceed this. So that's an important point to make. So how does this, we started thinking about like, well, how does this affect our efforts, tremendous efforts to sort of mitigate habitat loss with nature-based solutions, and in particular, living shorelines. And this is sort of our thought on that. So these are just some pictures from the website Florida Living Shorelines, and a couple of descriptions, tried to get them throughout the state of Florida. And what you'll see is they all have in common two things. One, you'll see there's an oyster bar. Here's an oyster bar, right? Here's an oyster bar. These are recycled oysters in what used to be plastic, but are now in biodegradable materials. And those are designed to be a wave break. Okay, so living shorelines are designed to do two things: stabilize the shoreline and create habitat that was lost through urbanization or shoreline erosion. So, and with that, then an improvement in water quality, an improvement in the bugs and bunnies that need wetlands and so forth to live on. So most of them will have this wave break, so that reduces the energy. And then behind it, they'll plant native wetland species, whether those are salt marsh or mangrove. Okay, so those are the two components. There's usually a wave break, and then there's your vegetation behind that. And this has been going on for over a decade now. But what we noticed was in this example, you could see here the shoreline is erosional because there's tree stumps and things as the shoreline has been migrating landward under conditions of sea level rise. But here, the installation, it has room to migrate, right? It can just migrate right up onto the beach, which will be wetland over time as sea level rises. So there is this sort of accommodation space for it. And these other examples, and more typically, they're installed to create habitat that might have been lost because of the presence of a seawall or riprap, or maybe somebody has a damaged seawall and they say, I'd rather put in a living shoreline and help, restore the elements of the estuary that were lost over time. But many of these have this, and the question and the consideration that we posed is, well, what happens to these installations as sea level rises? Like, where do they go? And in many cases, living shorelines are important as education and outreach, right? Just the very construction of them is an important part of coastal resiliency. But in cases where the long-term goal is to create new habitat that helps to reduce water quality impairment and so forth, then we may need to be thinking about other ways to select sites that will be more resilient to sea level rise. So just, the scale on which we are installing or looking towards nature-based solutions is just mind-boggling, right? Here's just a screen grab of a NOAA Restoration Atlas I got, I don't even know, a week or month ago. And there's hundreds of coastal habitat restoration projects just within the Gulf of Mexico and the Atlantic seaboard there. And many of those are nature-based. They're all nature-based, and a lot of them are living shorelines. So there's an enormous amount of money, of resources that are being committed to this, and it is a substantially and significant aspect of our, tools in the toolbox, if you will. So that's sort of the context in which we launched this project, and I'll show you how that works. But just so you know, right now the Future Shorelines application, we've got a number of projects. The one that we just finished and that I mentioned was up here in the Indian River Lagoon, so East Central Florida, and dipped into the Treasure Coast region. We just initiated a project, or will initiate one, that will extend the living shorelines down through Palm Beach County. So basically, we'll cover all of the Treasure Coast. And we have also initiated a project to apply it down here in the 10,000 Islands, the Rookery Bay National Estuary and Research Reserve, where we're using it to evaluate the vulnerability of the built-in natural environment within the refuge to sea level rise. So what I was going to do here this afternoon is give you some examples of how this can be applied. And I think with this, as you all ponder on the approach, there are a number of different threats to or opportunities to enhance resilience. So we're going to start with the living shoreline example, but I'm also going to show you how we used it to evaluate the resilience of a boat ramp, mini boat ramps, spoil islands, on-site treatment and disposal systems, or septic and wastewater treatment plants. So we'll provide examples of how this tool and how we think about planning for the future under conditions of rising sea level. So let's start with living shorelines. So here's an example in Melbourne, Florida, here on the Barrier Island. So here's the Indian River Lagoon, Causeway, 192. And you can see the oyster breakwaters here. Been installed, so that reduces the wave energy. Why is that important? Because then the plantings have a higher probability of surviving. If you just plant, mangrove propagules or sprigs of salt marsh and the waves are pounding, they really have no chance of surviving. So this is to augment. And then these also, once there is recruitment in that, the oysters can filter like 50 gallons of water a day. So they help to clean the water as well. So the combination is impressive. All right. So we're going to look at this part of the shoreline. So I'm going to go to find this. So this is the home page for the Future Shorelines. It's at futureshorelines.fiu.edu, the landing page. And there's information up here about the team, funding, some publications. There's even a tutorial and so forth. But we just click on that and then agree to whatever it is that fine print says. And then this is sort of the tool. And what you'll see here is there's a map or plan view of, in this case, the study domain that we did on this project. This could easily be the Treasure Coast. And we'll just click on the satellite overlay there. And then there's a drop-down menu. And in this case, we've got parcel data. So this is a parcel specific. You get parcel specific information. Then I'll show you here these elevation transects that'll be displayed over here. We have demographic indices. This is the digital elevation model that we used to understand. But elevation is extremely important if you're thinking about sea level, right? How high are you? So this is the DEM data that we use, and this is from Florida Division of Emergency Management, their 2017 data, their latest data. So we have that, but this can be populated by anything. We even have the UCF shoreline characteristics, which I'll show you here in a second. But this could be anything. Specific to living shorelines, this is what we put in. So what I'm going to do now is go to this particular installation, and you can search. So that's a parcel ID right there. And if I got to copy that because I'm in. So if we go up here and we put in parcel ID, this is the search bar, paste in our ID, it'll fly you into the location of interest, which is this location that I was directed to earlier, right in here. And so we can, let's say here, click on this. We see that it is owned by the town of the Atlantic, and there's some information. And we had done this because when you're looking for living shorelines and so forth, where you might want to put them, it's, who owns the land, right? Most of them are on public property, but, private individuals may be interested as well. So that's our location. And then if you go down here and there's these dark lines, and these are elevation profiles that we put in here, right? So we click on that and click on that. This is the elevation of the land across that profile. And what you could see here, there's, of course, the installation is along here. You can see it's very steep, right? And if we put on the UCF data, we can see the reason for that is trying to a little bit of a. You can see there that there's riprap all along there, right? So we feel that the slope is important when you're thinking about living shorelines because they can migrate inland over relatively flat land, but steep gradients, they're going to have a problem, as I illustrated, riprap, seawalls, and so forth. And in fact, if we've calculated the slope, so this is again for practitioners that are thinking about living shorelines, and anything over 5 degrees we've coded as blue. So these are just the slope between two data points, the average slope. And the blue means it's too steep. It's too steep for the shorelines to migrate. Therefore, their resiliency and their probability of performing their intended ecosystem service over time is low. But you could also, I don't know why I just changed this for a second to get rid of, not sure why okay, so what you could do is, this isn't behaving, you could pick a time, here the intermediate high, and a year, and the model floods both in plan view and in cross section where sea level will be. This is mean high water, and it's specific to this location. We use the V-datum transformations of NOAA, so the lagoon is not a flat surface, has some variability to it. We've incorporated that in here. But you could progress through the various sea level trajectories and see how the landscape, both in plan view and cross section, will behave, right? And so one could, if they were looking, maybe there's a whole bunch, they've got a bunch of installations, resources are tight, which ones do we prioritize? This could be one consideration. Well, if the goal here is long-term performance for the purpose of ecosystem services, water quality, so forth, and maybe we don't continue to invest time and resources here. We pick another one where the slope is lower and the resilience is more likely. So that's an example of of our living shorelines. And I'm going to show you another example here, which has to do with boat ramps, right? So boat ramps, they provide ecosystem services, right? They commercial and recreational fishing, ecotourism, sporting, resident quality of life. And we dialed this in for you all here. Using the FWC boat ramp finder, we identified 26 motorized boat ramps in the Treasure Coast. And these are just color-coded to distinguish between the counties. And what we did was we looked at, using the tool, what effect will sea level rise at 2050, 2070, and 21 have on the boat ramps, their services. And as you'll see in all the examples I'm providing, we had 3 different classifications: partially submerged, still functional, largely submerged, not functional, and totally submerged. All right, and so obviously not functional. So I'm going to show you the south limb of St. Lucie down here. So we're going to go to the Charlie Lighton boat ramp. So I'm going to take this. I'm going to go over here and put in coordinates, paste that in, and go. So here is the ramp. Right, we'll go on here. It should say it's owned by Martin County. Okay, we'll click on let's get one where the ramp is itself. So let's see, I'll take off the parcel data. So here's the ramp. You can see here the elevation profile of the ramp. So I'm going to put in, what is it going to be in 2050? So not a lot going on. It's relatively steep, not a lot of rise. I'm going to do 2070, compromised, largely submerged. So we did this for all of the motorized boat ramps in the Indian River Lagoon, talking today about Treasure Coast, right? And we went through this. Not affected, partially, largely, or totally. So 2100, not only is the boat ramp submerged, but so is, most of the area. So when we did that for all of the motorized boat ramps in the Treasure Coast, so there's 8 in Indian River County, 8 in St. Lucie, Martin County, 8. I checked. That's not just a coincidence that they're all 8. Here for, well, you can see, the tool allows you to look at, regional or site-specific evaluations. So there's data for all of these ramps, specific time intervals. But in general, what we could say is that, by 2070, the vast majority of the boat ramps in the Treasure Coast will not be usable. So that gives you a time frame. You can look at it in more detail and figure out which ones are we going to lose first, which ones are more vulnerable, what do we want to do about that, and there's time to think about that. Next, spoil islands. So again, we spoil islands perform ecosystem services. They're recreational. They've been classified by FDEP as either recreational, they provide conservation, or in some cases critical wildlife habitat. So here's a map of that, and the color coding is just between the recreational and the conservation. I'm going to show you an island right here in a moment. But again, we just kind of said partially submerged, largely submerged, no longer functioning as intended, and totally submerged. So we're going to look at a spoil island here in Indian River County. Coordinates, put those in. And this is actually Island 35. It's a conservation island. So there we go. Let's go, what's going to look like in 2050. So that's partially submerged. 2070, largely submerged. And in fact, this is probably just a little air in the LiDAR. That looks to be a canopy. And then completely submerged by 2100. We'll zoom back out. You can see quite a bit is as well there. But again, if you're thinking about spoil islands and their contribution to your ecosystem services, is there something that can be done to mitigate, or are there other ways to plan around and provide alternate services? Again, specific locations at specific times, you can evaluate and quantify the threat. So here we did it for all of them, and this is actually the aquatic. This is just within the aquatic preserve. But again, you can see there's 38, 22, total of 60, and there are differences in between the counties, but all considered. Here you can see the vast majority of them are non-functional in 2050. So all of them will be underwater, essentially, except for 1 or 2. And those are largely submerged. So again, not the best news, but it's data that can be used for long-term planning purposes. So next, septic systems. We use this as an ecosystem service proxy. A lot of counties are putting in considerable effort to try to convert to municipal services or do the newer advanced performance systems in here. It's a monumental task based on data from the Florida Department of Health. Uh, we got 82,000 known or likely OTSs within the Treasure Coast, within the Indian River Lagoon watershed of the Treasure Coast in there. We're gonna, I didn't have time to do specific examples for the Treasure Coast, but I'll give you one up here in the Merritt Island in Brevard County. So here is the present. So these are known or likely septic systems. And remember, these are below ground features, and sometimes the location, surely the elevation are rarely known. But then we just flooded. Here's 2050. You can see this is all but the underwater here. Here's 2070. There's some flooding adjacent to septic in certain areas, so you would assume that is releasing partially or non-treated wastewater septic. And here in 2100. So we did this computationally. We did the graphic for Merritt Island for another presentation, but we calculated those. And here is for the Treasure Coast. Indian River County, almost 30,000, 36,000. Martin County, almost 1,700. All the data. There's your 82. And then here is when the parcel is inundated. So what I mean by that is, because this is a little tricky. So this parcel has been identified as having known septic. So when sea level encounters an edge of it, we say it's inundated. There's could be more sophisticated, but it's a first step at trying to quantify the magnitude and the location of this threat really to water quality. But in all cases, of course, there is an increase, and by 2100, looks like about 9,000 of them, the parcels themselves are inundated. I'll come back to that in a minute. Wastewater treatment plants. So we looked at 6 within the watershed of the Treasure Coast, and again, partially submerged, functional, largely non-functional, totally submerged. So we're going to look at the SHI wastewater treatment facility in St. Lucie County. So let me grab that off a different screen. So there's the nuclear power plant. Here is the facility. And I'll take off those. So here we have 2050. This would be partially submerged, but no impact on surface features. 2070, largely submerged. And then 2100, completely submerged. Lastly, I think I have, oh, here we go. So different, each county, 3, 2, 1, total of 6. This is interesting. Here's Indian River County. The one that is completely submerged, this is the same one. It's been moved or is going to be moved. The point is that at least $175 million, but that project is have been approved, and I know there's a lot going on with that, but roughly, that one will be out of the way. Here's the Fort Pierce. I believe they've commissioned the new one, and the old one they're decommissioning, and that is one of the two. So these are nice examples of planning ahead. I think the Fort Pierce took 25 years from concept to actual construction. And that's something that we need to consider as we think about the impact. And of course, the impact is when these are inundated and fail and so forth, we have, pollutant loading to the Indian River Lagoon that triggers, well, you all know about that. So not to mention just the city service. So, but again, where and when. I want to also talk a little about seagrass because we've started to use it for that as well, which is the keystone species or foundational species for the Indian River Lagoon. So this is a cartoon here of typical, cross section. So there may be an urbanized area where there's a hardened structure, a seawall, a rock revetment, whatever. And then maybe where we have a natural shoreline, might look something like that. So here's sea level. This is the tidal range. And this is the median depth limit. So for those of you that are unfamiliar, the lagoon has been mapped, and with respect to seagrass and median depth limits, it's been subdivided in, I think, like 21 or 19 segments. And each of those has a unique median depth limit, which is sort of the average depth below which there's no seagrass, because seagrass needs light. So they kind of figured this out, and they hindcasted, trying to using historical photography and other things to say, where should we be with our seagrass? So there's the median depth limit. And as you see, the seagrass sort of peters out. It is not present below that. There's not enough light. And, the problem has been as the water clarity and quality has degraded, then the median depth limit of the grass, that amount of light is reduced, and so that rises. So improving water clarity and quality causes more light and allows seagrass to expand into deep water areas that it couldn't under the existing water. That's the theory. But as sea level rises, right, so does the median depth limit proportionally. So in areas where you have no a place to go, you get what's the coastal squeeze. You lose your wetlands. If depending on the bathymetry, there may or may not be any seagrass. You bathymetric grounding, deep areas we lose. Where do we see seagrass potentially surviving is where they can migrate and stay within that median depth limit. So we also modeled that. We had bathymetric data. We had the median depth limit data. And of course, we had the topography around the edge of the lagoon, so we could see new areas like this. We could quantify, and we looked at, well, how theoretically how will seagrass change if it's business as usual? And what we found is, here's Volusia County, a decline from 4,000 acres. This is 2006 data, and when there was more seagrass than there is today. So this is conservative estimates, low, I'm sure low. Brevard County, interesting. You get a decline because the water gets deeper and there's bathymetric grounding. But in Brevard County, there's an increase in the latter half of the century because sea level's flooding basically Merritt Island and all the conservation lands, which gives area for the wetland and aquatic species to move into. And because Brevard County has the most amount of acreage and seagrass, then there's actually a slight increase overall, although it's below the starting condition there. So just a couple caveats here before I wrap up. We did not consider the presence of groundwater or the effect of stochastic random processes, right? So groundwater floats on seawater. And those of you are probably aware that groundwater is getting more and more attention, right? Because areas will, the presence of the groundwater could be a couple of feet above sea level in the coastal zone. As sea level rises, the groundwater rises, and depressions will be filled first with fresh water and then ultimately with seawater. So we didn't consider that, but the numbers are still stark. And we didn't consider right, and I just point out here that, your wastewater treatment, there's conveyance systems that bring that to the treatment center. Septic tanks are under ground. So we're conservative in that the impact of sea level rise on those systems and the release of toxins and pathogens and so forth will occur well before they're completely submerged. And we didn't consider tropical storms, cyclones, increased storminess, drought, all these kinds of things that just really wreak havoc on the system here. Oh, and there's a lot of other applications that we're just now dabbing into. Topographic recontouring or beneficial use of spoil. There are considerations of taking some of the spoil islands and recontouring them so that as sea level rises, they are high enough that seagrass can colonize them. We could also use it to track property ownership. In some cases, the living shorelines were constructed in front of public land, but in 10, 20, 2050, whatever, the shoreline is now adjacent to private land. So then that brings up issues if, assuming that there's still people around to manage it, like how do you get there? Do you have permission? How are you going to do your monitoring, your maintenance, and so forth? And another one is this concept of restoration or land acquisition, helping target like where should we prioritize land acquisition or restoration or removal of obstacles. I mean, there's just an infinite number of opportunities. So just not always to end on what can be done. And I know this is the purpose of your speaker series and your organization in general here. We have to improve water quality and clarity, and with wastewater and stormwater, targeting to improve the seagrass and so forth. And again, submergence simulations like this can identify and prioritize what should be done first or second and so forth. The buffer, I think, is kind of something that we don't really think about, but certainly now in south of Brevard, the natural lands adjacent to the lagoon there are some, but not many. Is there the possibility to acquire and specifically not for what they are today, but what they might be tomorrow, removing obstacles, and then always public education and outreach. So that is my presentation. Let's see if I got it. Hopefully I turn that off. There we go. Stop sharing. Are we good?
We're good. Thank you, Dr. Parkinson. Any questions for him? There's one in the chat. It sounds like this was briefly mentioned, but how do you and your team get buy-in from private property owners with constructing living shorelines? Are there outreach efforts your team has undertaken to areas identified as being vulnerable to tidal flooding and sea level rise?
So when we develop this, so we don't interact, we don't build living shorelines. What we've produced here is a tool. So I think there were 12 partners on this product that I just showed you here. So Volusia County, Brevard County, Indian River County, St. Lucie County, Martin County, FWC, NOAA, DEP, St. Johns River Water Management District are a few that come to mind right now. They were all involved and helped us from the beginning. It was a 2-year project. And so they said, for example, we would like to see the transects go back 500 feet. We'd like to see them spaced at 100 feet. We'd like you to use feet and not meters. So the tool was designed to accommodate their needs. And then as at the end, we got even more feedback to where, like, could you put in bathymetry? Could you put in seagrass? So that to help facilitate the permitting process for living shorelines. Could you use Florida trajectories like that are used, for example, in the slip application. And so we have been working closely through what is co-production um, to ensure that the tool can be used by these folks in the decisions regarding living shorelines to start with. But we've also had it used, St. John's has kind of used it to consider topographic recontouring of some spoil islands. So I guess to answer your question, we aren't um, involved in any of that. We're providing support through this tool and through our partnerships with those different groups. Hope that answered your question.
Okay, there's another one. In other parts of Florida, would your model distinguish between likely habitat migration, upland areas for marsh versus mangroves?
So yes, I don't know the marsh versus mangrove is a little more complicated, but we are actually um, going to we thought about, and we're going to hopefully start this with that project that I mentioned that extends down through Palm Beach County. We're going to be adding, expanding right now we were just within the current watershed of the Indian River Lagoon. We might expand that and then identify conservation lands, have land use for undeveloped land, so that one can be, and then as that is submerged, the cross sections that you saw will indicate where the submerged lands might be appropriate might be colonized by wetlands, but it will also guide one in like where do we acquire and restore uplands in order to provide migration space for them. So your point is astute, and we are thinking about that as well. So the model doesn't really just stop at the shoreline, but it looks up the watershed and into other areas that will be flooded in the context of trying with wetlands and other natural lands perform important services for the residents.
Okay, any other questions? Uh, with that, thank you, Dr. Parkinson, and I will move on to the next portion of our series, which is the announcements.
Okay, so thank you. Thanks for the invite. Anybody feel free to reach out to me if you would like more information or copies of the papers and things that we've written, but we're happy to help. Okay.
Yep. Thank you so much again. So just some brief announcements.